You probably know that carbon dioxide and methane are greenhouse gases, which means they trap heat in the atmosphere and contribute to global warming. But did you know there are huge amounts of these gases stored in a strange icy state in the ocean? They're called hydrates, and they're formed when water molecules surround gas molecules and freeze them into solid structures. Hydrates can be found in different places in the ocean, but we're going to focus on two types, one that contains carbon dioxide or CO2, and one that contains methane or CH4. Now these hydrates act like caps that keep the gases from escaping into the water and the air. But there's a problem. The ocean is warming as carbon emissions continue to rise, and that could melt these hydrates and release the gases. Well, why is that bad? And what are the potential problems that could arise if these hydrates continue to melt? Well, sit back and relax, because this episode is going to be interesting. I'm your host, MrEarthGuy, and you're listening to Earth SciShow. When it comes to greenhouse gases, CO2 is the most common, and it's responsible for about 3/4 of emissions. And not only is it the most common, it also remains in the atmosphere for thousands of years. Methane, on the other hand, is less common, but it's much more potent. In fact, it's at least 84 times more powerful than CO2 over 2 decades. These contrasting differences between the greenhouse gases are really important, as the effects of them can be determined over the short scale and the long scale. Now here's where things get interesting. See, the oceans absorb 1/3 of humanity's carbon dioxide emissions and 90% of the excess heat generated by increased greenhouse gas emissions. It's actually the largest carbon sink on the planet. If the warming seas melt these hydrate caps, there's a danger that the oceans will become big carbon emitters instead. This will have grave consequences for climate change and sea level rise. It sounds scary, right? But how likely is this to happen, and how much gas are we talking about? Well, that's where things get tricky. Scientists are still trying to figure out how many of these reservoirs are out there, how big they are, and how susceptible they are to melting. Some of these reservoirs are located near hydrothermal vents, which are cracks in the seafloor where hot water and minerals spew out. These vents create superheated fluids rich in carbon or methane that rise towards the surface. When they collide with the cooler water, hydrates form and trap the gases in subsurface sediments. These reservoirs are deep in the ocean, so they're hard to find and hard to study. But some scientists have discovered them using sonar or seismic imaging techniques, or by sending robots and submarines to explore them. They found reservoirs of liquid CO2 or methane bubbles under hydrate caps in places like Japan, New Zealand, and the Pacific Ocean. But let's be clear. These reservoirs contain lots and lots of gas. For example, one site on a volcano in the Pacific was estimated to have as much CO2 as 0.1% of all the CO2 emitted by volcanoes on the entire mid-ocean ridge. And that may seem small, but remember that this is just one site among thousands along a 40,000-mile-long system of underwater volcanoes. The risk these reservoirs pose depends on their location and depth. Some of them may be stable for a long time, because they're too deep or too cold to be affected by ocean warming. Others may be more vulnerable, especially if they're near upwelling currents that bring warm water from below. The melting of these hydrates could release CO2 and methane into the oceans. This could affect two things. Firstly, it would acidify the water and harm marine life, and secondly, some of the gas could escape and reach the atmosphere to add to global warming. And you're probably asking, how do we know that this hasn't happened before? Well, actually it has. Some scientists have found evidence that CO2 or methane from seafloor reservoirs were released during past periods of climate change, such as the end of ice ages. They analysed sediments and ice cores to trace the origin and timing of these releases. They found that these releases coincided with spikes in atmospheric temperature and sea level rise. They also found that these releases were not gradual, but rather abrupt and massive. They've suggested that these releases may have triggered or amplified global warming events in Earth's history. So what does this mean for us today? Well, it means that we should try to be very careful about messing with these reservoirs. We should try to reduce our carbon emissions and slow down ocean warming as much as possible. We should also support research and exploration of these reservoirs so we can better understand their size, location, and behavior. We should also be aware that these reservoirs are not the only source of methane or CO2 in the oceans. There are other types of hydrates that form on the shallower seafloor at the margin of continents. These hydrates are more abundant and more accessible than the deep ocean ones, and they're also more sensitive to ocean warming. And what's more concerning is some of these hydrates in the shallower areas have already started to leak methane into the water and the air, especially in places like the Arctic where the ice is melting fast. And these melting events will cause a positive feedback loop. As more methane and carbon dioxide is released into the atmosphere, more warming occurs, and the oceans warm faster, which means more hydrates melt, which means more damage to the ecosystem of our planet. As you can tell, there's a lot going on under the seafloor that we don't know much about. But we do know that it matters a lot for our climate and our future. That's why we need to keep exploring and learning about these hidden climate time bombs and try to defuse them before they explode. And one of the ways to do that is to curb climate change to stop the oceans warming as quickly. And that's all for today's episode on Earth SciShow. I hope you enjoyed it and learned something new. Thanks for listening to Earth SciShow. It's been a pleasure. I'm your host, Mr. Earth Guy. And remember, stay curious.